once we know some right triangle stuff, the next thing to do is use that to define our trig functions. There's going to be 6 in total, but there's really going to be sort of a big 3, sine, cosine, and tangent. And one thing we're going to see eventually is that even there, sine and cosine are really going to be the ones that we use the most. We can kind of use sine and cosine to find all the other ones without too much fuss. So let's start with another generic right triangle. I'll kind of keep this picture relatively consistent to the one we were using before. So angle C, angle A, angle B, and then that's going to be right side A, side B, and side C. So when we're defining the trig functions have an angle as their input. And so what we're going to use is theta, which is a Greek letter. So it has an angle, theta, as an input. So you can use that either as an angle in degrees, right? 30 degrees, 60 degrees, 90 degrees, or you could do radian angles, pi over 2, pi over 4, pi over 6. In theory, the trig functions work for either, right? It's based on the angle. It's not necessarily based on the units. Obviously, you need to know which system you're working in before you sort of like do a calculation, but that's stuff for later on. At this point, so the input is an angle. So what we need to do then is decide on an angle to use here as like a reference angle or a perspective angle. I'll sort of pick the angle just like down here in the corner, I think, just to get started. That's a little bit sort of easier to work with. So theta is the input, and it's in the triangle, it's our perspective angle. So we're going to be sort of looking at this triangle and labeling all the sides from the perspective of this corner, this sort of corner B. So that's going to be our theta. So we need to label the sides. We said already, right, that the long side, side C, is our hypotenuse. So that's going to be our long side. And then the other two sides, A and B, I sort of mentioned briefly, they're either going to be the opposite or the adjacent. And so that's going to depend a little bit which is which, based on what our perspective is. And the way that I think of it is I always sort of identify the hypotenuse first because it's not going to move, right? It's across from the 90-degree angle. And then based on your perspective angle, what's going to happen is the side that's across from that angle, so the side that you're sort of like, if you were sitting in this corner and like looking out across the triangle, the side B, that's going to be what we call the opposite. So the opposite is across from theta. So our hypotenuse is the long side, and it's across from the right angle. Our opposite side is going to be across from theta, which is our perspective angle. Kind of then by default, the third side, which I said is the adjacent, must be side A in this particular setup. Adjacent, right, kind of means next door or like next to. So opposite means sort of across from, and adjacent means next to. So you can kind of see why this is named that way, right? So this is the side that's next to the angle that's not the hypotenuse, and then the opposite is across from it. So our adjacent is going to be the side next to theta, but not the hypotenuse, right? So the adjacent and the hypotenuse sort of both touch theta, but the hypotenuse is our long side, the adjacent would I guess be the shorter of the two, and then the opposite is across from the angle. So that's our sort of naming setup, and so we need these names because what we're going to do now is we're going to define all 6 of these trig functions based on the side lengths. So the input is an angle, so we define our 6 trig functions. So theta is the input. The input is an angle, right? So whether this is 25 degrees, 30 degrees, 32 degrees, we don't really know necessarily. But that's okay, depending on the situation. What we're going to do just to get our definitions here is the idea is, let's just sort of start into it. So our first function is called sine of theta. And so what we're going to do is write sin. And how that's going to be defined is it's going to be the length of the opposite side divided by the hypotenuse. So all of our trig functions, the angle value is the input, but what the result is, what we're really getting out of it, is a ratio of the side lengths. So in this case, it's the opposite side divided by the hypotenuse. So it's this sort of ratio comparison. One sort of thing to note, right, is the hypotenuse is always going to be a long side, longer than the opposite. So this, in theory, should be kind of 1 or less. Most of the time, it would be less than 1 as a value. So that's the sine function. So the full word is sine, but we're going to use the abbreviation sin. Do your best not to necessarily say sin. Right? This is the sine function, even though it looks like sin, which is sin. The next function is the cosine of theta. So that's cos of the angle. And the definition there is that's going to be the adjacent side divided by the hypotenuse. So the sine value is the opposite over the hypotenuse. The cosine would be the adjacent side divided by the hypotenuse. So what we're doing is essentially just going through all the different possible combinations of 2 of these 3 sides to make a ratio. So sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse. Our third sort of major one is the tangent of theta. So that's going to be tangent tan. And tangent is going to be defined as the opposite over the adjacent. So tangent is based on the 2 shorter sides. Both cosine and sine are going to have this sort of property, right, where it's an opposite or an adjacent over the hypotenuse. The hypotenuse is always the long side, so each of those are always going to be less than 1. Comparing the 2 shorter sides, the opposite and the adjacent, we could get all sorts of different results, right, because it really could be lots and lots of different relationships between those 2 side lengths. So those are our sort of big 3. Afterwards, what we get are what we call the reciprocal functions. So reciprocal, of course, means, right, like flipping a fraction, sort of 1 over. And so each of these have sort of a reciprocal function. So you can flip these ratios over, and you're going to get a new function, and they're going to be sort of linked together. So the first one is cosecant of theta. And so that's going to be CSC. And so the definition there is it's the reciprocal of the sine function. So it's 1 over the sine function, which means it's going to be then flipping this fraction. So it's the hypotenuse on top and then the opposite on the bottom. So cosecant, CSC of theta, is 1 over the sine function. Is going to be the hypotenuse over the opposite. The next one is regular secant, so secant of theta. So that's going to be SEC, and so that's the reciprocal for cosine. So 1 over the cosine of theta. So that's the hypotenuse over the adjacent. Need to leave just a little bit more space. We're getting just a little bit squeezed here, right? This lining up didn't quite work out perfectly, but the idea, right, is I'm trying to give you these reciprocals essentially in the same order. The third one I'll try to leave a little bit more space is the cotangent of theta. So tangent is t, or nope, I'm sorry, cotangent would be COT of theta, so it's 1 over the tangent. And so that means we're going to flip the adjacent over the opposite. Right. So these guys in green are our reciprocal functions. Trig functions. And then our guys in blue are sort of what I would think of as the sort of the big three, are sort of three initial starting points. Those are our definitions. I'm going to do a second video where we do some examples where we actually sort of take a triangle and find all 6 of these different values.